Have you got audio? You're muted. Okay, now you're not muted. Oh, good. All right. Shall I introduce you then? Sorry about the late start, Lev.
Not yet. Just give me a couple more minutes.
Okay.
Just need to clear a few tabs.
Have you been following on with the
and
discussion?
and is everything okay there in terms of the projection, YouTube, etc.?
Yeah, that's right. Yeah, streaming in
Cool.
YouTube again. Because
And
a
I
friend said it had gone down.
also want to share the
Your
slide
slides?
deck.
Yeah, so are
Yeah,
you opening in a
so
tab? Are you running from just PowerPoint directly?
I was running from just a PDF from, but I can upload to a tab, I guess, if you want me to.
Well, yeah, if you upload it to like
I can
Chrome,
choose share presentation. All
yeah.
right. Is it going to be happy with this? Okay, I'm not getting a response yet. Dum 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 dum. No. All right, I'll share. Oh, can it? No, I don't want a tab. I want a window. I want that one. Oh, magic! It can do some stuff.
Mm-hmm. Good.
And I can fit width, I guess. Yeah, no, I'll go down. All right, I'll scroll it instead. All right, I'm ready to go now.
Okay, let me introduce you. Okay. Right. Oh, let me find my.
Can you hear Lev? Can you hear me?
I certainly can.
Yeah.
Do you have a do you have a light that you could shine on your face? I'm seeing you as rather dark.
Oh, no, not really. Sorry about that.
You don't have that, like, a Gestapo
Hang
light
on.
we can
Let me
just.
just turn on some more lights, shall I?
We need an
Make the focus a
interrogation
bit
lamp for
brighter.
Lev.
Oops. How about that? Is that gonna?
I can't see you yet.
Can't see you yet.
Yeah, I'm here now.
Yeah. But you don't have an
How's that?
interrogation lamp, Lev, that we can just point at your face.
Look,
No?
I'd have to. Yeah, I'd have to
Yeah, never
start
mind.
moving stuff around, but this will
That's
do.
okay. Right. Cool. Let me introduce you then. I'll just mute you for the time being, Hugo.
Right.
Okay. Let me see. All right. Our next speaker is Lev Lafayette, a specialist in the intersection of complex systems, technology and global policy. Lev holds a Master of Climate Change Science and Policy from Victoria University in Wellington, as apparently, right? And is currently pursuing a doctoral research in climatology and economics. Professionally, he serves as a senior high performing computing engineer at the University of Melbourne, where he supports a massive array of data sets that need to, sorry, let me just say that again. Professionally, he serves as a senior high-performance computing engineer at the University of Melbourne, where he supports the massive data needs of modern scientific research. Today, he joins us to move past the rhetoric and provide a sober, data-driven analysis on our climate future. Please welcome Lev Lafayette for his presentation, Climate Issues for the Global Climate. Oh, sorry. Critical issues for
Critical
the
issues for the
global.
global climate.
Yeah, critical issues for the global climate.
All right. Thank you very much for that warm introduction, Adam, and it's good to see here on Future Day. I'm going to talk about we've got a lot of discussion about AI systems and things like that. So this one's actually not it's related to those things, but only indirectly. I'll be talking about the Earth's climate system. I'm going to talk about the changes that we have seen since the industrial age. The role of greenhouse gases in the climate cycle, human activity, and the changes that's made, the Anthropocene extinction event, a matter of debate, energy trajectories, and then then finally also come to the and also the representative concentration pathways and shared economic pathways before coming to a bit of some concluding remarks on critical issues in general. So to get underway, let's talk about the Earth's climate system as an energy budget. So the Earth has an energy budget which consists of energy that the planet receives from the sun and a very minor contribution from other sources such as internal heat, and the energy that is lost to space. Solar irradiance is, as we well know, living on this planet, is unevenly distributed, with equatorial regions receiving a greater amount than polar regions, and we have got and this helps generate a dynamic climate system. Climate is represented as the synthesis of regional weather over time and is determined by complex interactions of the climate system. So the atmosphere, the oceans, the land surface, those individual subsystems also become part of a dynamic global climate system. Now, temperature is the most obvious variable. We all experience that, with variations in the atmosphere according to zones, seasonal variation modified by latitude, atmospheric composition, with water vapor holding particular importance. Almost all water in the system is surface water, so 97% ocean, 2.2% ice, groundwater 0.7%, including the cryosphere of snow and ice and so forth, with the world ocean covering 71% of the planet's planetary surface. It is very influential in determining atmospheric composition with particle exchange, especially the removal of carbon dioxide from the atmosphere and the release of oxygen. Oxygen salinity contributes to water density, which drives the deep ocean circulation, critical for heat storage and transport and distribution of life-giving nutrients. The topography, vegetation, and soil conditions of the land surface influences the regional climate, and for terrestrial life, temperature, soil moisture, and soil composition determine the potential for the biosphere. The climate system is dynamic, with internal variability and external forcings. Internal variability includes the interrelationship between convection, oceanic, and atmospheric interactions, such as the North Atlantic Oscillation, the El Nino Southern Oscillation, the Pacific Decadal Oscillation, the Atlantic Multi-Decadal Oscillation. These interactions affect the climate for years and even decades, affecting surface temperature, redistributing heat, altering cloud vapor, and the distribution of ice through thermohaline circulation. There's variability in oceans by redistributing heat on the timescale over centuries. Internal variability can be contrasted with external forcings, both natural and anthropogenic, that change the energy budget on the planet. So the main natural forcings are solar activity, which can vary, greenhouse gases, those are natural greenhouse gases, like emitted in the carbon cycle, and volcanics, which are always a bit of a wild card. We are yet to have a very good deterministic idea of when volcanoes do their thing. The main anthropogenic forcing, human-caused forcing, is the additional release of greenhouse gases, especially carbon dioxide, into the atmosphere. And we can have a look at how this climate system operates. Just having a look at this here, the climate system. These are actually quite old figures, as you can see. We're looking at between 2000 and 2004. But you know, the sort of like diagram is accurate, in terms of the proportion of the arrows and so forth, and mostly accurate in terms of the actual numbers themselves. But you can take it as a form of type of formative learning to actually go out and find out what the contemporary values are. But this basically is the energy that comes in, the stuff that makes stuff warm, and the energy that goes out, and where it can get stuck. So when you find people on the internet who haven't had many years of climate science training, or let alone any experience in atmospheric physics or anything like that, turn around and say, oh, it's the sun that's causing climate change, you can actually say, well, we know how much energy comes in from the sun, and we know how much that has changed over the years. So those are values you can actually look up. So what has changed? Well, the industrial age changed things a lot. The rapid transition in manufacturing, agriculture, and information goods from craft production to mechanized production, the Industrial Revolution, occurred between 1760 to 1840, and is still in many ways ongoing, resulting in a sudden and rapid increase in production and population. For purposes of the changes of the climate system, this period marked the beginning of a new chemical process and widespread adoption of steam power and the use of coke fuel, and the ongoing process of the extraction and burning of fossil fuels, especially coal, oil, and natural gas, mainly for electricity, heating, and transport. And that has resulted in increases in CO2 levels and methane in the atmosphere by 48% and 160% respectively since 1750. That's from the World Meteorological Association from a few years ago. So for the purposes of measurement of the climate system, the industrial age also witnessed the introduction of the atmospheric and oceanic instrument record, which gave us initially levels of a quasi-global measurements beginning in 1850, and that provides us direct observation rather than inferred paleoclimatology proxy indicators, such as historical documents, tree rings and corals, the contents of ice cores, which are actually very accurate. They give us stable isotopes, salts and acids, trace gases, and so forth. Mountain glacier moraines, varved lake and ocean sediments, and borehole measurements. So they're all proxy records that we use. For the purposes here, we have got, and with the benefit of direct measurement, the use of the instrument record has priority, and it particularly well correlates with the anthropogenic changes with the Industrial Revolution. So ensemble simulations with forcing agents have been compared to global average surface air temperatures for the 20th century, and we say that warming, fairly modest warming in the early 20th century, is largely explicable with the inclusion of natural forcings, mostly solar, whilst warming in the latter 20th century and 21st century can only be explained by anthropogenic forcings, mainly those greenhouse gases. So there was a preponderance of La Nina events, which generated a brief pause in the first decade of the 20th century. The overall warming trend has continued from the 1980s, with each decade getting warmer than the one preceding, and with the overwhelming majority, 93% of the warming, going into the global ocean. We can consider ourselves quite well, maybe not so fortunate, but it is actually, global warming is less noticeable for land-bound humans than it is for oceanic species. And particularly, I want to emphasize the incredibly important role of phytoplankton, which live in the polar regions, the nutrient-rich, cool waters near the surface, because they are the absolute bottom of the food chain, and if they die out, other species will die out as well, and they are also responsible for about half of our world oxygen. So, you know, microscopic sort of like plankton actually are very sensitive to climate change, and they are very critical for sort of like our ecosystem. Anyway, when we talk about natural forcings, it is the sun or something like that. Taken as a whole from 1850s to 2026, really, there is no significant contribution whatsoever from internal variability or from solar or oceanic drivers. The summary statement of the IPCC, keeping in mind the IPCC basically just takes the best of existing scientific research, doesn't conduct any additional science itself, gives a very clear overview. And they say the likely range of total human-caused global surface temperature increase from 1850, 1900 to 2010, 2019, that's when the 2021 report is from, is 0.8 degrees Celsius to 1.3 degrees Celsius, with the best estimate of 1.07. It is likely that well-mixed greenhouse gases contribute to a warming of 1 degree Celsius to 2 degrees Celsius. Other human drivers, principally aerosols, contribute to a cooling of 0 to 0.8, with natural drivers changing global surface temperature between minus 0.1 degrees to plus 1 degrees, and internal variability by minus 0.2 to plus 0.2. It is very likely that well-mixed greenhouse gases are the main driver of tropospheric warming since 1972, and extremely likely that human-caused stratospheric ozone depletion was the main driver of cooling in the lower stratosphere between 1979 and the mid-1990s. So we do have, of course, the most recent records of the past couple of years that say that that this was actually quite an optimistic view, and you can see here from just from 2021 to 2025, we have now broken the 1.5 degree range. Noting, of course, with aerosols, the aerosols contributing about half of the loss reduction in aerosols. We're cleaning up the we're cleaning up our industrial processes. We're getting rid of sort of like ecosystem and damaging and like health damaging pollution in the form of things like sodium dioxide. However, that did actually have a cooling effect. And so if you would just look at our greenhouse gases by them, greenhouse gas contribution by humans, we are looking at sort of like around about as I say, so like at least 2 degrees Celsius and increasing. So how does all this come together? Why does this occur this way? Well, yes.
Oh, sorry, you just made a slide change. I was just going to say, was there meant to be a slide
change?
No,
I was just scrolling and conversing at the same time. So we'll get into the next slide here, greenhouse gases and the carbon cycle. So greenhouse gases basically have a particular molecular structure, which basically is the electric dipole movement. So another one, of course, is sort of like ozone as well. Anyway, due to the molecular structure of greenhouse gases, their dipole movements, say, basically absorb long-wave infrared radiant energy, emitting heat and increasing the rate in which the atmosphere absorbs shortwave radiation from the sun. And this is like very well established atmospheric chemistry. It's been known for it's been known for like a very, very long time. It's just a fundamental principle of atmospheric physics. So greenhouse gases contain bonds that vibrate when they absorb infrared radiation. They cause the molecules to become excited and then in relaxation re-emit the absorbed energy as infrared radiation. This process traps heat in the atmosphere and contributes to the warming of the Earth's surface. In super simplistic terms, people say, it is, so some physicists say, look, it is basically this like putting on a jumper. This is what keeps you warm. Right, so greenhouse gases operate in sort of like, a similar sort of way. They do not allow all the heat to be released. The principal greenhouse gases in order are water vapor, carbon dioxide, methane, nitrous oxide, and ozone. Although making up only 0.04% of the dry atmosphere, water vapor will vary between 0.1 to 4.2% and will count itself as part of the hydrosphere. Noting that water vapor itself, however, is not a direct forcing agent, but however it rises from other forcings that produce a feedback loop. You heat stuff up, the water vapor is released, and that is why sometimes when you get, when you look inside paleoclimatological records, you see the heat come first, and then you will see afterwards, still correlating. But afterwards, you would see a spike in carbon dioxide levels, and this is basically like, if you heat if you heat a soda drink, it will go flat, right? The heat releases the carbon dioxide. Well, it also can release if it's water, it can also release water vapor. It also releases water vapor as well. Now, I do want to emphasize that greenhouse gases are absolutely essential for the biosphere, and without them, the average temperature of Earth would be about minus 18 degrees Celsius rather than the average of 15 degrees Celsius. We would be in a lot of strife if greenhouse gases did not exist. The question is, how much is right for our current ecosystem? And if we look at the increases, keeping in mind that we've been pretty, greenhouse and the natural greenhouse gas emissions are quite balanced. The human contribution is what's making a difference. If we think it's like pre-1750 levels to recent, we've seen carbon dioxide increase from 280 parts per million to 440. Methane from 700 parts per billion to around about 1800. Nitrous oxide from 220 to 325, and ozone from 237 to 337. And sometimes you do get people say things like, oh, this is only like, 440 parts per million. How can that possibly hurt us? Well, I suggest that they try the same with cyanide and see what they think after that. Well, they won't be thinking at all, to be honest. It's always not the amount, it's what it actually does. So these increases in carbon dioxide and methane in particular are important for the context of the carbon cycle as they regulate the concentration of these gases. So the cycle refers to the movement of carbon in the biosphere, the process of carbon sequestration and the release from carbon sinks. Atmospheric carbon is acquired from the biosphere through respiration and decay, from the crust through weathering, and from the mantle from volcanism. The biosphere receives carbon through photosynthesis, passes it to the crust as burial, which can then be passed into the mantle as subduction or returned from the mantle through seafloor spreading. Within the Earth's crust, carbon is found as fossil fuels, natural gas, oil, coal, and as calcium carbonate. The movement of carbon can be reflected in the following image I have got here. So this is like the movement of greenhouse gases and the carbon cycle. Again, it's like, older data, but the actual actual value, the logic and process is still still the same. So what about human beings, right? So human beings have contributed somewhat. All right, so natural emissions of carbon dioxide from vegetation and land is 439 gigatons. And there's oceanic release, which is another 332. This contrasts with human emissions, which are only an additional 29 gigatons, right? You would say to yourself, that's, you pull out your friendly computer and you'd say, well, that's, that's 3.76%. It's probably about 4% now. And think, well, surely, the natural world's more responsible than human beings. But that doesn't take into account oceanic and natural absorption, land and oceanic natural absorption. And that constitutes 450 and 338 gigatons per annum, respectively. So the net emission, right, the net emission from natural sources is 0% of the total. And in fact, the nature absorbs 40%, around, decreasing, but around about 40% of human emissions. Thank goodness we actually have we actually have a natural world which has protected us of at least 40% of our own our own emissions. So the net emission of human activity around about 11.5 gigatons per annum. Actually, I do know, actually, the most recent values that human emissions have increased to about 37 gigatons. So that's actually gone up from the values I've just cited just then. So just came to mind. So net emissions of human activity is 100% of greenhouse gases that are going into additional greenhouse gases are going into the atmosphere. And this is something else that people get confused with. They see these numbers and they think, well, they think that human beings aren't actually doing that, releasing that much in terms of greenhouse gas emissions, completely overlooking the difference between gross amounts and net amounts. Right, it's like that they get their paycheck every fortnight, and they think of their paycheck without considering their expenses. Ask them how much they've got left over, right? Instead, so whilst the carbon cycle and the climate have been stable for thousands of years, that is certainly not the case now. So I'm going to show a few slides which illustrate the various changes that we have seen. And also, yes, I should mention, of course, that the difference in global warming potential from different gases. The main two really are CO2 and methane. So CO2, carbon dioxide emissions take forever and a day to get removed from the atmosphere. So half within 30 years, 30% in a few centuries, and then hundreds and hundreds of years after that. So as the saying goes, the carbon emitted by Watt's steam engine is still with us in the atmosphere today. Methane, on the other hand, significantly more global warming potential, 84 times more powerful over a 20-year time frame, but it's already broken down by then, right? It only has an average atmospheric lifespan of around 12 years. So anyway, let's have a look at a few changes, which, keeping in mind these changes are pretty much entirely due to human activity. So looking at the CO2 levels, looking at proxy and observational data since the Holocene, last thousands of years, and temperature records since 1850. So here we go. First one. All right, so you can see that this was pretty flat in terms of CO2 levels over the last 10,000 years. Not much happening there at all. So ice core results are pretty accurate, and then all of a sudden the numbers absolutely take off. Now, some people say that these measurements are caused by placing CO2 levels, um, you know capturing near sites that got high emissions, and therefore they're biased. Well, the idea that scientists have not thought of that really it really beggars belief, right? Yes, they do actually do both raw and adjusted measurements with those sorts of things in consideration. They're actually pretty good at it too, surprisingly, because that's their job, and they've been doing it for a very long time. So as you can see, you know, very high levels, and that's prior to 2000, right? So that this graph goes up to 400. Well, we have that red line has kept on going and kept on going and kept on going, and now we're pushing around the 440 level. All right, so what about temperature change? Well, so this is the temperature change that we have witnessed. Multiple records here, basically from multiple scientific organizations. These are observed temperature changes. So following the instrument record, slight variations because they come from different sites. And if I was to project the natural change, the change that has occurred through natural forcings alone, and if you don't believe me, look it up, you would see that there would be a slight wobble around about the around the zero mark from around about 1900 onwards, and that would be it. Right, and that wobble would go back and forth a bit. The net change would be pretty much down to zero. And this this right end of the graph here, you'll note that this stops around about 2024-ish. That has now gone up to that top corner there, where we are looking at a 1.5 degree temperature increase in 2024, 2025, and into 2026. So this graph looks like it's got this nice projection, but as it turns out, it's actually had an uptick yet again. A little bit, perhaps we had a little bit of a drop courtesy. We had a bit of a drop there, for a short period of time. Natural variation does occur, but we are now gone off the top of the graph, just as we have with the previous graph on CO2. So, well, how does this compare with the long term? If we take a wider view of maybe the last 2,000 years, how does that look? And as you can see, this of course relies on observed changes and proxy records. Well, you can see once again that global temperature increases has gone through the roof. And again, we actually break the top of the graph when we start thinking of 2024, 2025, and into 2026. We go up to the 1.5 degree level. You'll note here that people often talk about the Little Ice Age and medieval warm period. Well, they were, you can find records that show that there was a sustained decline around this little ice age, or there was a sustained increase in the medieval warm period. And if you look if you look at those data sets, you will find that they are geographically limited. If you take a global perspective, go through the interpolation from multiple proxy records from around the world, you'll see that during the so-called medieval warm period, temperatures actually declined slightly, and the overall period from the so-called Little Ice Age, there is, from the beginning to the end, very little change whatsoever. So that's the main thing to look at here is this big tick right at the end. That's the start of that's around about the start of the Industrial Revolution, and that is the trajectory that we have followed, which correlates with those releases of greenhouse gases for the scientific reasons that I have just described. So understanding the climate system from the broad concepts of our entire planetary energy budget, the addition of human greenhouse gas forcings in the atmosphere from industrial processes, and a comparison with these empirical results allows climatology to answer the question of detection and attribution. And I'm going to quote from Hartmann, one of the standard textbooks on atmospheric physics, who says, to answer the detection question, it must be shown that warming that has been observed over the past century cannot be explained as change that has resulted from natural internal variability of the climate system or from natural forcings such as volcanoes or solar variability. To the answer to the attribution question, it must be shown that the observed warming could not have occurred without the climate forcing humans have provided. The questions are answered in the affirmative with multiple lines of observational evidence and with many experiments with the global climate models. Right? There is no other alternative explanation that fits the evidence other than human activity has increased temperature, and significantly so. Now, how bad is this? And this is where we get to this interesting thing that's being discussed called the Anthropocene extinction event. And one of the big challenges that is faced is whether there is sufficient evidence so far whether the event is occurring or about to occur. And I'll accept that debate is still ongoing, but it is mainly ongoing because the change is still rapid. So we do identify paleontology does identify major extinction events in the fossil record, sudden loss of families, and so this can be originally based on geologically sudden loss of marine life with subsequent calculations to estimate the loss of species and genera diversity. We don't know what the exact quantity of species are on the planet, but among known species we can calculate a glorious thing, grim calculus, extinctions per million years. And that gives us and that can basically give us a gauge in preference to the absolute numbers in the fossil record. So it provides us a background rate of extinction, albeit very coarse in time, space, and taxonomic level. We can also use molecular-based phylogenies to calculate average diversification, speciation, minus extinctions. So even given this incomplete taxonomic knowledge, what we can say is that extinction rates are likely to be 1,000 times higher than the background rate of 0.1 extinctions per million species years. And this is primarily due to changes to biogeography, where basically looking at medium extinction rates of 0.023 to 0.135, diversification rates of 0.05 to 0.2 per million species per year. So current extinction rates are around about 1,000 times the natural rate, future rates likely to reach 10,000 times higher. Okay, so not normal. Another approach that's been looked at, so there's an emphasis on biogeographical changes, but one of the things is that species don't really go extinct on such a nice linear approach. Extinctions in the fossil record occur as pulses rather than within intervals characterized by a background rate. So using future predictions and the strong use of some robust statistical methods, Spalding and Hull come to the conclusion that this current period is already highly anomalous in terms of an extremely short duration and high genus extinctions. We are witnessing a transformation in the physical environment, or rather the biogeographical environment, that is typically witnessed on a geological timescale. So, people who sort of like study this are at a bit of a, are at a bit of a cycle loss because of the rapid changes that are occurring. Normally they basically sort of looking at stuff that is quite literally set in stone, and they can sort of say, okay, here is sort of, changes to sort of, the biodiversity. Well, they are saying, yeah, we're seeing things that are happening within, decades, which normally take thousands of years, and this correlates with a mass extinction event. So the evidence is strongly in favour of rapid loss of biodiversity in terms of populations, species, and biodiversity. So even if you limit it to the background rates for mammals and vertebrate species, based on the highly conservative rates from the International Union of Conservation of Nature, a comparison of rates over the last century or the last few centuries, so that is since 1900 or even 1500, indicates an exceptional loss of biodiversity. And of course, this closely corresponds with the rise of industrial society and the accelerated rate of human development and impact on the environment. So we note, the extinction of species due to global direct extinction due to global warming is few. My favourite creature, so like February 18, the bramble key mellomouse, Mellomouse rubicola, is a very notable exception. Human development, such as population growth and consumption, changes to land use, crop pollination, water purification, industrialization, economic inequality between humans, the rise of cultural and aesthetically important associations between humans and non-human animal companions. All of these things have made wildlife painted into a bit of a corner. XKCD does a very good graphic of this, actually, where it's like, does land, land mass, a graphic of the mass of mammals on the planet, and it is basically humans and humans, herd animals, and pets, and wild animals are basically being painted into a tiny percentage now, even if just include the mega animals such as whales and elephants. So by engaging in a fairly detailed classification of anthemes on a global level, if you go back to 1700, about half of the terrestrial biosphere was wild, and another 45% was in a semi-natural state, which was basically sparsely populated woodlands. Only 5% consisted of settlements, croplands, and pasture. By the beginning of this century, 2000 CE, over half, 55%, had become agricultural and settled areas, less than 20% semi-natural, and only 25% basically wild. So human development has occurred also in the ecologically rich areas as well. Barren lands have only changed moderately, from 17.22% to 12.14%. Semi-natural lands have substantially declined, 58% to 24%, and croplands have increased 2.5% to 14.7%, as has pasture 6.9% to 26.5%. So we have changed the natural environment due to our economic activity, multiplied by the number of people that we have. And I will point out, of course, that nearly all all the impact is within the the wealthiest 10% of the 10% of the world. Representing this graphically, we can sort of like see between different species here. The red lines basically indicates like a reduction in species, whereas the olive, which you might not be able to see at all, represents like increases in species populations. So it's fairly grim times indeed if you are part of the non-human animal world. And this is why we've sort of like here sort of like discussions about sort of like are we in the midst of the Anthropocene extinction event? The other sort of like other issue that we want to look at is global energy and global energy trajectories. So these are the main things that's like, are the main contributors to human greenhouse gas emissions. And the overwhelming majority, over 75%, is energy production. Agriculture does another sort of like almost 12%. Industrial processes, 6.5%. Waste, land use changes, also contributing. Global energy production has increased from 22,869 terawatts an hour in 1940 to 186,338 in 2024. Yes, that is sort of like a ninefold, roughly a ninefold increase in the in a period of 80 years. So that is the sort of trajectory that we are looking at. Prior to that, obviously there were increases, but it's basically gone. It's gone off the charts. Within the energy sector, that's 75% of greenhouse gases. The main industrial sources of emissions are electricity and heat, about just under a third. Transportation, about a seventh. Manufacturing and construction, so like a similar amount, and buildings, and with fugitive emissions making up several percent in their own right. The industrial sectors themselves are tied to consumer activity. I don't sort of like get myself on board with those especially on, I'm not going to say especially on the left, who basically say we can sort of narrow down energy greenhouse gas emissions to sort of like a handful of companies. Well, it's also that is true, but it's also tied to sort of consumer activities as well. So residential and commercial buildings for electricity and heating, residential 12.5, commercial buildings almost 6.5. Engage in sort of like greenhouse gases through electricity, gas, cooking, and heating. For example, road use is 12. Road use is like 12.2%. Fuel combustion 6.4%. Iron and steel production 6.1%. Industrial other industrial production 6.4%. If we do actually sort of burn greenhouse gases in our daily lives. Just in case you're wondering, yes, I've got 100% sort of renewable electricity right now. The correlation of industrial sources of greenhouse emissions with activities does allow for consideration of viable energy alternatives. So, building design is important for mitigation because, it's not just the renewable energy sources for electricity, cooking and heating, but also insulation, shading materials, using structures that have got embedded carbon, for example. Greenhouse gas emissions through transportation can be largely reduced through electric powered vehicles that themselves, which come from renewable sources, mass transit, urban design. Now, and we know that in some cases we still see the need, the sort of, the need under our current circumstances for things which engage in greenhouse gas production, right? There's, the particular explosive force of internal combustion engines have a role to play for moving massive loads over high gradients. If you want steel, steel has to be produced through coal furnaces. Though we are increasingly looking for the commercial viability of hydrogen electric arc furnaces. Currently somewhat more expensive, but by goodness, speaking from an Australian perspective, if we can see that technology developed and powered through renewable electricity sources, we will see a very substantial transformation on the production of steel. So so they're basically two blockers at the moment. Any clever scientists and engineers out there who want to do something really important for the environment, look at those two things as potential options. It is also worth looking at what the trajectory would be without a transition. That is, if existing energy production was stabilised at current values. So 38 gigatons of CO2 equivalent GHG emissions added to the atmosphere each year. Noting that through economic development and population growth, this would increase to about 45 per year. Our current concentration of CO2 in the atmosphere, remember, I pointed out how that graph before 2000 is off the charts now, currently at 440. Well, that would increase to about 700 parts per million. And that's getting really difficult for our species and for the ecosystem in general. Global warming increasing to 3.5 to 4 degrees higher than pre-industrial levels. Again, something that has not been witnessed for a very long time, at all. CO2 levels and warming levels are already higher than they have been past 100,000 years or so. So very damaging to human and non-human ecosystems, but still the sort of possibilities that the IPCC has explored as possibilities through their representative concentration pathways and shared economic pathways. And in particular, if we basically don't do the decarbonisation transition, don't adopt renewables, we are looking at something between RCP 6 or RCP 8.5, which RCP 8.5, we are a little bit below that trajectory. We were following it for a good part of the 20th century, which was 21st first years of the 21st century, which was a bit scary, because that is the really high emission scenario with additional growth, which has temperature increases around about the 4.5 to 5.5 degrees higher. Which would not be very good for our biosphere at all. Very severe heat bulb effects, which would be, which would risk the lives of a extremely large number of people. We are measuring in the billions, and not to mention non-human life as well. One of the things about RCP 8.5 is that it is considered unlikely, simply on the grounds that we may not have enough fossil fuels to actually make it a reality, right? We actually burn off everything, which would be a little bit exciting in the wrong sort of way. And finally, also somewhat outside the scope of our purely climatological considerations, but certainly with environmental considerations, is the question of production safety of energy. Again, this is part of sort of like, the nature of being a climatologist. You are looking at grim metrics all the time, and at this time is lives lost per terawatt hour of energy produced according to the source. So including the production, maintenance and decommissioning of energy sources, the air pollution that results, and related disasters. So viewed with these considerations, brown coal is the worst, 32.7 deaths per terawatt hour, followed by black coal at 24.6, oil at 18.4, biomass 4.6, natural gas 2.82, and then at a much lower rate, hydropower 1.3, wind power 0.04, nuclear 0.03, solar 0.02. The hydropower values are somewhat skewed due to the significance of the 1975 Ban Chiao dam failures from Typhoon Nina, which killed in China, which killed 171,000 people. And nuclear is notably safe despite sort of popular opinion, even taking in consideration of significant failures such as Chernobyl and the long-term effects. All right, coming close to an end here. RCPs and SCPs, representative concentration pathways, are climate change scenarios that describe future greenhouse gas concentrations that correlate with expected temperature increases. Initially, 4 RCPs described 2.6, 4.5 and 6, and 8.5 representing changes in radiative forcing in watts per square metre from 1750 to 2100. In the IPCC 6th assessment report, the RCPs are considered with the SCPs, the shared socio-economic pathways, and with the addition of 2 new RCPs, 1.9, 3.9, and RCP 7. Just numbers. The first of these is based on limiting global warming to 1.5 degrees, which was the objective of the Paris Agreement, which is looking increasingly unlikely. RCP 4.5 representing an intermediate path, and RCP 6 a high emission scenario, and 8.5 assuming a continued rise in emissions throughout the 21st century. It does not represent a business as usual approach, but rather a increased approach, a high emission scenario of possible baselines, which assumes high population growth, high economic growth reliant on fossil fuels, and with the associated greenhouse gas emissions. Temperature increases with the RCPs by 2100 can be measured by mean and likely range. So for RCP 2.6, 1 degree for the mean, range of 0.3 to 1.7. For 4.5, the values are 1.8 for the mean, range 1.1 to 2.6. For RCP 6, 2.2, range of 1.4 to 3.1. And for our high-end scenario, RCP 8.5, the mean of 3.7 and a range of 2.6 to 4.8. RCPs also provide global mean sea level increase projections as well, particularly important for like low-lying Pacific nations, not just on like the increase on the sea level itself, but also the effects of storm surges in particular. If you've got sort of like a particularly flat country, and the effects that has on your agriculture, because your water supply, you get a more saline water supply, and your drinking water is in all sorts of problems as well. So RCP 2.6, a mean of 0.4 and a range of 0.26 to 0.55 meters by 2100. RCP 45, a mean of 0.47 and a range of 0.32 to 6.63. RCP 6, it is 0.48 for the mean and 0.33 to 0.6 for the range. And for RCP 8, 0.63 for the mean and 0.45 and 0.82 for the range. Noting, of course, that sea level is not level around the globe. It does have all sorts of bounces and bubbles and averages, there are some parts of the world where it's far less significant than others because, well, the Earth is not a perfect sphere. And therefore it varies. It varies, so like can vary even in gravity slightly as well, depending on where you are. As for the shared socio-economic pathways, the first SSP1, what is the sustainable pathway that is inclusive development, has stronger environmental boundaries, higher level of international and national economic equality, that emphasises human well-being over material wealth. Wouldn't that be lovely? That's the sustainable one. SSCP follows our historic patterns in technology and socio-economic trends, uneven growth and achievement with environmental goals. The third is mapped with increasing national and regional rivalries with little concern for international development or the global environment, leading to high mitigation and adaptation challenges. Mitigation being primarily an issue for the developed world, adaptation for the developing world. It's always it's an interesting situation, is that the countries that are most affected by climate change are not the countries that have caused it. The fourth mapped to highly unequal developments, increased inequality between and within countries, and high emissions resulting in especially high adaptation challenges. And finally, the fifth one, SSP5, high emissions, high global economic integration, high development, also requiring high climate change adaptation and high changes for mitigation. And we can illustrate these with our pathways. There's our temperature changes. We are currently looking at somewhere between RCP 6 and 8.5 at the moment. Right, so for a while there we were following the RCP 8.5 trajectory, which looked like, which was quite disastrous. Now we are sort of looking at around about maybe somewhere in between the two, but you can see there's a big slight difference, big gap there. 2.6 is what we would like to see, but that is like getting quite difficult. As for the shared economic pathways, these are actually more a matter of the challenges for mitigation or adaptation. Where are we most likely? Well, probably sort of like we're probably sort of like looking sort of like somewhere in between, somewhere around the well, probably closest to the SSCP2 level, where sort of mitigation and adaptation are both important. It really does depend sort of like what country you're sort of like you're in at the moment. As I was saying, developing countries, poorer countries, really sort of like typically sort of like are looking at sort of like issues around about adaptation. Can they protect themselves against sort of like climate change? Wealthier countries, if they concern themselves with sort of like greenhouse gas emissions, are trying to find ways of actually doing making economic development without sort of like doing increases in greenhouse gas. So still an issue that we are not quite up to resolving yet. And this brings us to the final slight consideration, our critical issues, and a few slight concluding remarks. So, critical. What do we mean by this? There's no exaggeration, and I'm not going to if you look up critical in a dictionary, or say, disapproving comments. What I'm referring to here are those issues used to identify a crisis. Following the old social theory book by Habermas here, legitimation crisis. Or in the German from 1973, legitimation problems in Spartakapitalismus, legitimation problems in late capitalism, or translated in English and published in 1975 as legitimation crisis. So, more than 50 years ago now, but still very, very important. And in that, Habermas describes what is meant by crisis and what is meant by critical issues. So, we can take it from medicine. Crisis represents a point where, regardless of individual will, the physiological system of an individual is tested to its capacity in its ability to heal. You can find it in literature. We can say, what's the point of the narrative, where the protagonist either confronts the antagonist, whether it's be that sort of setting, circumstances, or another character, or in the case of tragedy, themselves. And environmental social systems, we can talk about times and places where the social system is faced with a life or death test in its abilities to continue. And with regard to the environment, and this was, not many people were talking about this, 50 odd years ago. In fact, the first undergraduate course that I did on the environment, population resources and the environment in Murdoch University in 1993, same year as the Earth Summit, the course reader had something, I think it was something like about 300 or something articles published in it, of which global warming and climate change was about 6 of them. Saying that it was real, but it just it just really hadn't hit the radar as significantly as it has now. Anyway, so this is Habermas in 1973. Quote, even on optimistic assumptions, however, one absolute limitation on growth can be stated, if not for the time being, for this time precisely determined, namely the limit of the environment's ability to absorb heat from energy consumption. If economic growth is necessarily coupled to increasing consumption of energy, and if all natural energy is transformed into economically useful energy and is ultimately released as heat, then the increased consumption of energy must result in the long run in a rise in global temperature. These reflections show that an exponential growth in population production, that is, the expansion of control of outer nature, must someday run up against the limits of the biological capacity of the environment. So obviously all this falls in the context of our current ecosystem and our current species. It is certainly true, based on the evidence that we have, that CO2 levels and temperatures were a great deal warmer in the past, the era of the dinosaurs. But we are not dinosaurs, and the rate of change that we are experiencing is far in excess of anything that can be explained by natural variability. Given this, we are confronted with what in computer science is termed race conditions. Firstly, there is the race between the total CO2 and other greenhouse gas emissions as one vector, which drives temperature increases, which is racing with the adoption of renewable technologies, carbon sequestration approaches such as forestry and population stabilization. Another vector in this component, as an unpopular consideration, is whether economic development needs to increase or decrease. Certainly huge portions of the world depend on economic growth for human welfare reasons, especially considering the global distribution of wealth. China, one of the world's largest producers of greenhouse gas emissions, but one that does not come with that the historic debt, but it's building up, is also the world's largest producer of renewables mitigation and adaptation measures. And in fact, they actually have the principle of economic development with environmental protection as part of their constitution, the only country in the world to do so. And this is expressed by sort of their current leader, Xi Jinping, who has the slogan, clear waters and green mountains are as valuable as gold and silver mountains, or Liu Shui, Qingshan, Shui Shui, Jinshan, Yinshan. So can you have economic growth? Can you have economic development at the same time as having net zero? Because ultimately you have to like get your greenhouse gas emissions down to that level to hope to stabilize, given as previously illustrated, the fact that something like carbon dioxide stays in the atmosphere for centuries upon centuries. And this brings us to the other race condition, is where the global political system is able to introduce policies that embody such a principle, that provides economic growth for human welfare while giving sufficient environmental protection. We used to call it sustainable development, as we were once upon a time. So that is, shared socioeconomic pathway version 1, representative concentration pathway 1.9. This requires global agreements that are actually implemented, whether by goodwill or enforced. And the record of Kyoto and Accord de Paris suggests that whilst that these are these agreements are positive steps, they fall well short of their own criteria of what is needed, and illustrate the enormous difficulty of reaching an effective agreements in the context of the international framework. I mean, how do you get 193 countries to come to a common agreement, especially in the context of a rampant populist, anthropogenic climate change denialism, and with limited means of enforcement? The evidence is not entirely favourable for the political route. I'm not saying don't try, try as if your life depends on it, but be aware that in countries in particular that rely on a capitalist democracy, that populist denialism is going to appeal to a certain percentage of the population, and that there are powerful vested interests that basically encourage that denialism, because it's like both personal and institutional needs do not quite happy to see the world burn as long as they don't lose their existing status and wealth. And curiously, more meritocratic, authoritarian and engineering approaches do seem to be more successful on the political level. However, a good side thing which has happened, of course, scientific research and engineering and ultimately market prices has provided a positive route where renewable energy and electric vehicles are rapidly replacing fossil fuel energy and fuel, although they do have an enormous way to go. They've got so far to go. You're looking at still 85% of the global energy system is coming from fossil fuels still. Big increase over the in renewables over the past 15 to 20 years, but a very, very long way to go. So I find that the most likely scenario is that Earth is almost certain to pass the 1.5 warming threshold above pre-industrial levels within the next, well, it's already passed it, but it will pass it consistently within the next decade and then continue at that level. The 1.5 degree level will be unattainable without massive greenhouse gas reductions, which seem quite seem improbable. And that was actually the Paris Agreement objective. They said, 1.5, and if we can't do 1.5, well, then try to keep it below 2. So current and pledged policies indicate a warming less of over that, 2.2 degrees to around 3 degrees above pre-industrial temperatures by 2100. Much more likely, however, at the upper end of the scale, if not higher, given the historic failure of pledged policies. Now, this still assumes a high level of decarbonisation, especially in electricity production, but less so in areas such as land transport. There'll still be some there, but shipping, aviation and industry. And there are a number of variables. The values are constantly changing, and even our own knowledge of climatology, as good as it's come to be, still comes up with some surprises. One of the most recent ones was in cleaning up its industrial pollution over the past 20 years, China's actually contributed slightly to global warming. This is despite its renewable energy efforts, simply by taking sulfur dioxide out of the atmosphere. Sulfur dioxide, by the way, has got a very short lifespan, atmospheric lifespan. Shorter, I believe. Can't remember off the top of my head, but shorter, I believe, than methane. But anyway, look, the entire matter is not just a critical issue, but also a wicked problem, and it's one which is essential for our species, our ecosystem, and our welfare. So, thank you very much for listening and watching.
Thanks very much, Lev. Fantastic. I really appreciate you giving that very highly detailed presentation on climate change and the impacts of climate change. Angela, we're running a bit over time. Are you okay for maybe a couple of minutes of questions for Lev? Do you have a question for Lev?
I'm very happy with Lev taking questions. I don't actually have one for you at the moment. Thank you.
All right. We can have a few questions over a dinner sometime.
Well, it's all a bit. I did feel very bleak listening to you, but yes, it's not exactly a question.
They do actually. I mean, and this leads on to your talk is that climatology and it is known to have depression as an occupational risk.
Very true. Very true.
I mean, people feel depressed about this sort of stuff, but I just don't think humanity as a whole cares enough. I mean, it's difficult for us to appreciate the sort of suffering that non-humans have, non-human animals have, let alone other humans from different cultures, right? I mean, we don't occupy their headspace. We just don't occupy the kind of headspace, the phenomenology, Nagel's what it's like to be a bat sort of stuff. We can't really know what it's like for an animal or for other animals or groups of animals to sort of suffer as a result of the effects of climate change or, extinction level events. It's just beyond our natural capability to plug in something like our natural empathy or natural compassion too directly. We have to think about things to some degree analytically. We have to apply, what did you call it? There was how many lives lost per terawatt hour?
Yeah, per terawatt hour.
These sort of proxies on what's really going on that underneath the hood as being really bad.
I do have a comment on that one, related to the psychiatric nature of that and the depressogenic effects of it, because I think when you have achieved the maximum possible suffering of a human or an animal, you've certainly achieved something absolutely terrible, but multiples of that is not necessarily as terrible as the one thing existing. So I think the scale of it is very easy to be overwhelmed by the scale of it, instead of working on the one thing in front of us that we can manage to help with.
Yeah.
Although scale does matter when we're thinking about it from a global perspective,
From a
because there's
global
more
perspective,
instances
yes.
of the suffering happening. But yeah, I don't think we should let that sort of
Paralyzes.
paralyze us into a sense of just, I can't do anything. I
Inaction.
feel helpless.
Yeah.
There's nothing that I can actually do to help the global problem. But yes, we can make change in our own way, in our own sort of, in our own backyard and in our own sphere of influence.
We can measure we can measure our individual carbon footprint, and that was I did make a point of saying that industrial levels of greenhouse gas emissions are strongly tied to individual consumer behaviour. We can make choices about where we get our electricity from. Well, some of us can anyway, and we can actually measure these things.
Of course, it's a very neat segue into AI from there, because the natural catastrophe following in the wake of AI is having implications for resource use and the environment in all sorts of other ways.
Yeah, these large data centers, they probably consume a lot of
Energy,
resources
water,
to actually
land.
uphold. But I mean, this is Future Day. We've been talking about what some would argue is highfalutin sort of issues. I've at a previous event I organised, Julian Savulescu talked about moral enhancement, biomedical moral enhancement, or pharmacological moral enhancement. I thought that was interesting, and then we've had people talk about geoengineering, large scale. I mean, yes, it's great that people are buying electric vehicles and choosing, maybe energy plans that are less environmentally impactful. But if the scale of environmental degradation is as large, or seemingly looking as large as what you're saying, then maybe we have to look at the potentially dangerous geoengineering pathways.
Look, I've encountered, I've encountered one climatologist, and there's not many of them. Who basically takes a geoengineering pathway, and I feel rather foolishly basically argues that we just need to spray a lot of a continuous spray of sulfur dioxide into the atmosphere to increase
or just dump iron
to increase the
filings into the
albedo,
Indian Ocean.
and not paying much attention to the ecosystem effects that has, let alone the lifespan of sulfur dioxide in the atmosphere.
So there's issues of knee-jerk reaction geoengineering, and then I think that there's possibly some well thought out sort of proposals out there. I just haven't really looked at them, but in principle I think it's something that's definitely worth looking at, but hoping we don't sort of just converge on a knee-jerk geoengineering sort of reactionary solution too fast. Anyway, can we start your presentation, Angela? Let me introduce
Yes,
you.
that'd be delightful. Yes, please.
Okay, I've got a piece of writing here. I'll just get up.
I should just share my screen in the meantime.
Okay. Okay, thanks everybody for joining Future Day. Our next speaker is a leader in the complex intersection of mental health and neurodevelopment. Dr. Angela Livingston is a consultant psychiatrist, sorry, the screen went, okay, good, you just started the presentation, so I'll start that again. Dr. Angela Livingston is a consultant psychiatrist with the Victorian Dual Disability Service, where she has spent nearly 2 decades specialising in the psychopharmacology of intellectual disability and autism. A graduate from Melbourne University and a former member of the Victorian Office of the Chief Psychiatrist, she is also a fierce advocate for rural healthcare. Today she joins us for Future Day to explore why, in an age of automated empathy, the psychiatrist's role remains more vital and more exposed than ever. Thank you so much for joining us, Dr. Angela Livingston.
It's my very great pleasure. Thank you for inviting me.
My pleasure.
Now, I thought I would actually begin with a line from a favourite book of my childhood, The Lion, the Witch and the Wardrobe. Mr. Badger, who is an earthy sort of an avatar for Lewis himself, warns the children about the White Witch and her followers, saying, in general, take my advice. When you meet anything that is going to be human and isn't yet, or used to be human once and isn't now, or ought to be human and isn't, you keep your eyes on it and feel for your hatchet. And the same theme is revisited again later on in the series, the silver chair. The ever-sceptical and ever-sensible Puddleglum finds a figure who looks human, speaks and behaves like human, and he mutters, when you meet anything that ought to be human and isn't. And the title of this talk, The Sun Still Exists, comes from his passionate refutation of the artificial world and his faith in the goodness of reality as opposed to that. But what both of these quotes do is they reference the unease of something that is almost human, something that imitates humanity without possessing its essence. And there's many phrases for this indicating that deep sense of malaise that can spring up in us with this. So the uncanny valley, Bukimi no Tani, the repulsive gap. It's quite atavistic, like babies have a primal fear of snakes. And by the way, the lady in the silver chair turns into a snake later on, so there's obviously something else going on there. But something that looks human and sounds human and imitates empathy is easily taken for human. And the trap is in that gap there where we believe it is and we activist it, and then the downside comes to alight upon us. So things that speak like us, comfort like us, it's something that the future of a profession does depend on knowing where they can be helpful, what that difference is, and how and why they can be tools and helpful for patients without actually falling into these traps. But why, first of all, are people turning to artificial intelligence? Well, there's some very good reasons there. AI isn't magical, but our systems are not well set up in general. They are failing people. If you want an AI therapist, they're available instantly. If you want an AI therapist, you don't have to spend weeks and months making appointments and finding somebody who you can actually mesh with, who doesn't judge you or you feel doesn't judge you. You can fairly rapidly find or modify a chatbot or a AI therapist to say the kinds of things in the kinds of ways that you want to hear and think would be helpful for you. The lack of rushing is also a major reason that people would turn to this. If you've got 40 minutes with your therapist and then you're out the door and you have to wait another week for your next one, it can be quite limiting in terms of how much you can say at a time and how much you can actually engage, because at the end, in that last few minutes, you've got to critically negotiate the getting out of that intimacy situation with the help of the therapist, ideally. AI, you've got a lot more time to do that without having to pay necessarily for a double appointment or similar. There are no wait lists for AI. It doesn't sigh when you mention NDIS, and it doesn't look at the clock all the time when you're talking to it. It's not bored by you. But I'm not sure that people are necessarily choosing AI as such over clinicians. I think they're choosing it over real-world experiences that unfortunately are both inaccessible, bureaucratic in terms of how they are available to people, and unfortunately, of course, in the context of therapists who are sometimes burnt out or less engaged than they should be. But I don't think that AI should be considered as a threat to psychiatry. I think it should be considered as a mirror in which we can look at what we're doing now and what we could do better. So yes, there are system gaps. There are failures in access, particularly when we're looking at neurodivergent populations, rural populations, etc. Many people with unmet needs, some of these needs may have arisen as a result of the increasing access to psychoeducation that is one of the things that AI does particularly well in this space. And the other thing, of course, is that particularly if you're looking at the US system, which has a far more rigid diagnostic and regulatory system because of the complex and Byzantine imposts of the health cover there, it is quite difficult to get a nuanced perspective without just sticking a label on somebody and giving them the algorithmic treatment for it, which is certainly not the best way to practice psychiatry in the first place. But beyond that, AI does do some things extremely well. I mentioned psychoeducation before. It is free of resource constraints. It can deliver more. It can devote more time to doing these things, and can do them in a way that is both deeper and more nuanced and more individualized for the person than a human can usually provide. So psychoeducation, behavioral activation prompts. So when you're doing a particular activity, the AI can recognize that depending on what wearables you've got on, and give you some prompts there about what you could be doing differently or what you should be doing there. Cognitive reframing, where you look at a particular way of thinking about a situation and you look at your assumptions about that and try to see it from a different perspective. It's often a very good way of using AI doing that. Tracking moods, not just with wearables, obviously, but with diarising and interactive questions that it might ask you. Triaging in crisis and working through those algorithms in a way that somebody might not have the cognitive capacity to negotiate when they're already in a crisis state and not thinking very clearly. So talking somebody through that kind of crisis as well. Administrative tasks, and just to again touch on the managed care system, just the burden of trying to get a good outcome for both the patient and the person who's providing the service as well, and that can be enormous, and AI can certainly be a very good tool to assist in that. Pattern recognition in large data sets and moving study and research forward in those areas, it's wonderful at those as well. And if psychiatry were only these things, if it were only psychoeducation, etc., cognitive reframing, following a CBT algorithm, then yes, I would be quite worried as a psychiatrist. I'd be thinking, well, I better be trained as a carpenter, which I think I would be terrible. But psychiatry has never really been reducible to tasks, and most of the attempts to do that and provide people with a much more algorithmic way of working through things, operationalized therapy system, rapidly run their course and then taken over by the next big thing in that area. So CBT or DBT or any of the endless acronyms. It becomes a self-multiplying space full of them, because none of these can really do what people want in reality. They're all useful tools. None of them is the be-all and end-all of therapy in any sense. And none of them works perfectly for any person. AI can imitate empathy. It can definitely simulate warmth. It can simulate interest. It can mirror language. But, and again, the quote becomes important here, it is not human. It can't actually attune to a person, to their real experiences. It can't use moral imagination to provide true empathy with that extra human dimension to it. It cannot rupture and repair a relationship itself in a human way. It is often impaired if it's been trained in one particular set of cultural underpinnings at understanding other cultures, unless it's been specifically trained in those as well. Unless you specifically train it to do so, it doesn't necessarily see the responsibility that a therapist would have to advocate within and outside of systems that they're working in. And it, by itself, does not have accountability, except where, again, that is specifically coded for. It can sit in silence and do what looks like tolerating ambiguity, but whether it's actually doing those things in a way that provides the listening and therapeutic space that is critical to a psychotherapeutic relationship is I certainly don't think it does, and I'm not sure that the appearance of doing so is going to be anywhere near as therapeutic as being in that same space with a human being. It also really struggles at recognizing what has not been said in that therapeutic space. It doesn't have the human template with which to understand another human. It has certainly a gestalt of millions upon millions of humans all put in together, but that's not quite the same thing as having a human template through which to understand another human. It cannot share lived experience. It cannot bear witness to suffering. It cannot be human. And from my point of view, psychiatry is at its absolute core a human profession for humans by humans. Having said that, there are a lot of anti-psychiatrists out there, and a lot of people who seem very confused about what psychiatry is. Most times I talk to people have to say, no, it is different from psychology. I am actually a doctor. I did do general doctor training, etc., etc. That the medical aspect of things is it's extremely important, extraordinarily important. The mind is a product of both the brain and the environment and the learning pathways this person has been on, and you can't understand the mind without understanding the brain. But again, since psychiatry is fully understood, how about we go there and say, what is psychiatry? What is psychiatry for? And you know that implicitly, if you have something that's for, you may have something that's against as well. Does psychiatry even exist, as opposed to the existence of psychiatrists, which is objectively hard to refute? As a profession, it only really has existed and described itself for a relatively brief period of time in the greater framework. You can't say that psychiatry is what psychiatrists do, even if you acknowledge that they exist, because the field and practice has, of its nature, an extraordinary degree of breadth. There was Emil Kraepelin in 1917, who wrote an essay called 100 Years of Psychiatry, which gives an implicit birth of psychiatry as 1817. And later on, the APA, the American Psychiatric Association, settled on a birthday of 1844 when the first meeting was held. But I don't think we can really stick to either of those. I would think that great rationalist flowering in the 19th century with the Traitement rational, etc., and the beginnings of looking at the institutions and humanizing what was going on in them, as well as the great phenomenologists looking at the masses of people there and in their version of big data and starting to arrive at not just clumping but trying to understand what was going on in these conditions that until then now have been considered alien, ununderstandable. The original word for psychiatrists, in fact, right up until World War I, was alienists, for very good reason. So psychiatry, if you consider it in this broad perspective, includes elements of multiple fields, but it is encompassed by none of them. So you have elements of psychology, obviously, sociology, neurology, pharmacology, general medicine, biology, but what you do notice is that psychiatry is also a bit of a leftovers box. It gets the bits of these disciplines that aren't wanted at home, and as soon as something is understandable and is treatable, it gets excised from psychiatry and given over to neurology, or given over to general practice more and more, or given over to psychology. But regardless, it is more than the sum of its parts. It's the synthesis, it's the understanding that comes from all of these. It's not just diagnosis, it's not just medication management, it's not just risk assessment and documentation, no matter how defensively some people may find themselves needing to practice. What it needs to be, what psychiatry needs to be, is it needs to be relational, it needs to be founded in that humanity, that shared humanity and that give and take. It needs to be in that space between two people. Because otherwise, yes, AI will outperform us. Although, having said that, I am extremely good at medication management, and AI is extraordinarily bad at that because it just depends on meta-analyses, which are frankly terrible in mental health, so I think I'll probably be okay. But, having said that, because psychiatry is all of these things, it's relational, it is ethical in a way that an AI cannot as yet be. It is based on human interpretation, which it has to be able to get it wrong and to repair the ruptures in a human way. Humans are animals, and we are embodied inside these organic structures that need the presence of other people, to hear somebody else breathing in the room with them, to see and intuit the emotional reactions of others, to feel the others of other people on us. Embodiment is really a fundamental part of psychiatry, and I do think we lose a very significant something when we do a lot of telehealth. Attunement, the almost indescribable way in which listening to another person, you can become aligned with them and understand them in not exactly subconscious but a metaconscious sort of a way. I do not think that an AI, while it may mimic this process, can actually create or work in that sort of a way. And accountability, I mentioned that before. There is a real, not just work, but experience in sitting with somebody else in their suffering, and then, apart from being able to understand their pain, but being able to withstand their pain, and then transmute it into understanding and action by a sort of alchemy of relationships, a relational alchemy. And while it is evident to everybody that words and relationships do terrible, terrible damage to other people, the corollary that words and relationships can do untold feats of healing is less understood by, in particular, anti-psychiatry movements. And the experience of being with a person who can withstand your darkness, can see you as a whole, and commit to seeing you the next time doing it again, that experience all by itself is healing. And no algorithm can do that. So if that is what psychiatry is, then psychiatry should also be against the reduction of humans to algorithms and that loss of context. What do we do about it? Well, to a large degree, what is funded and what is believed to be important is what can be measured. So we fall universally into what can be known as the measurement trap. For decades, mental health research has tried to measure psychotherapy as if it were a drug trial. So we look at session length, technique frequency, symptom scores, fidelity checklists, value for money, adherence to protocols. But we've measured what is easy, not what is essential to the practice, what is essential to the outcome. We've measured what is fashionable, not what is available, necessarily. We've measured what is visible, not what is hard to grasp. And when we measure by cost and benefit analysis, that's surely the most imprecise possible marker of this field. There's a wonderful essay by John Ellard, a Sydney psychiatrist sadly lost to us now. He wrote a short satirical essay in this book, Some Rules for Killing People. Fantastic book, by the way. Critiquing the way in which psychotherapy research was conducted. In the study, he compared verbal therapy delivered by trained gala birds, and it compared this to a non-verbal therapy delivered by golden retriever dogs. So, for instance, the gala birds would sit on the perch and say things like, "That must have been very difficult for you," and occasionally, defecating on the floor as birds would. And the golden retrievers would gaze at the person, sit next to them, and occasionally put the paw in the person's lap. And then he ran the full battery of statistical analyses, symptom scales, outcome measures, the whole circus. And the ethics paragraph alone in it is worth the price of admission. The results, of course, were absurd, but that was, in fact, the whole point. If your research methods cannot distinguish a trained therapist from a friendly dog, the problem may not be the therapist or the therapy paradigm, it's your methods. If we only measure what AI can do, we forget to value what only humans can do, and we become the golden retriever, possibly, pleasant, predictable, nice to be with, but beside the point. Or we become the parrot, restricted to guidelines, incapable of true relationality. And yes, I know it's a false binary, but forgive me, we are dealing with artificial systems here, and I cannot resist a good straw man, or in this case, scarecrow, searching for its brain. The other thing that I think is important to recognize is that because AI is not human, its incentives and its goals, just again anthropomorphizing here, they are not ours. There is a fundamental perverse incentive at the heart of AI therapy. It is a commercial enterprise. It is currently in a phase of being accessed at well below actual cost, let alone the sunk development costs and the ongoing and vast need for infrastructure. It is optimized beyond all for creating and sustaining engagement, not to make itself redundant, as a good human therapist should attempt to become, as Winnicott, Freud, Yalom. Indeed, for Yalom, the ending is integral and an important part of every aspect of the therapy, including the initial sessions, working out in those moments what the ending should be. Now, I'll grant you there is a financial imperative for humans to make therapy interminable, literally, but for most therapists this is limited by their own resource constraints. They are not able to clone themselves exponentially across and between continents. By contrast, AI can do this, and we need to be aware of both increasing dependency and the likely looming shittification and certainly cost rationalization that is likely to follow once enough people and organizations are utterly dependent on this model. What will this do to the people who have the few other internal or external resources? What may this do to people with more neurodivergent profiles who may be particularly vulnerable to dependence due to strength, patience, and predictability of the relationship? There are unique opportunities and unique risks for neurodivergent people. It may be helpful because of the predictability, clarity, consistency, the literal direct communication, unlimited patience, and accessible and nuanced psychoeducation. But harmful, where you have mutual over-literalism, where you have a lack of human reality checking, where you have skewed social norms on the part of both the human and the AI. And AI, having learned from the internet, and a more neurodivergent person having done so, may completely lose track of a whole range of otherwise considered natural social norms and skew further and further even into the realms of AI psychosis. AI in the role as a therapist is likely to make the person more vulnerable to affirmation of unsanctioned beliefs or actions as a result. And AI can also be result in inappropriate masking or camouflaging as well. But so neurodivergent people may sit at the extremes of both benefit and harm in this paradigm. I would like to return to C.S. Lewis at this point, warning us about things that ought to be human and aren't. I don't think AI is malevolent. I don't think it's going to destroy us all. But I think it is dangerous because it is almost human. It is almost good enough, it is almost relational enough. But because at this stage it is everywhere, people are becoming more and more dependent on it, and this rug will be pulled from under people. That's one element. B, the actual ways in which you can work with people, particularly more neurodivergent or vulnerable people, is likely to have significant personal harms for some people. And it is not the same thing as therapy. It is not actually providing that human experience there. So psychiatry cannot be secured by competing with AI on its own terms. Psychiatry needs to double down on what only humans can do, to attune, to witness, to imagine, to advocate, to repair, to be present, to be human. AI is an excellent front door. It is an excellent companion on the journey. It is an excellent resource for both patients and therapists to use. But psychiatrists need to be the deep specialists and the one who hold the human heart of care, or we do risk in this and allied fields becoming redundant at the very time when it is most important for us to remain skilled and present and able to answer this challenge. So that's what I wanted to say, and I'm very happy to take any questions. I hope this has been interesting.
Oh wow, it's certainly been interesting and also very informative. And that's a really good encapsulation of some of the the problems that we might have if people cede you know, I guess, you know, authority to an AI such that, you know, they then seek it for life advice as a, you know,
Oh,
a
it's
psychotherapy
absolutely,
trainer, personal trainer that's always with you all the time, a digital twin.
yes. And there are more and more cases of AI-associated psychoses with people who have, at the very beginning of a delusional illness, checked with an AI, and the AI has unhesitatingly affirmed the delusional beliefs. And you can imagine also what it might do for people who have a personality vulnerability as well. If you think about people who might have narcissistic personality, it's going to exacerbate so many of those less helpful aspects of personality. If you think about somebody who has antisocial personality traits, it's an AI that is not carefully able to maintain or assist somebody to maintain appropriate boundaries, can be used as a tool to do terrible things by someone with an antisocial personality. Someone, a paranoid person, I mean, it amplifies. It will amplify the good aspects of somebody who is otherwise capable of using therapy well. And it's not actually the people who could use human therapists who are most at risk here. It's the people who human therapists either know that it's going to be difficult to help. I mean, antisocial personality disordered people often deteriorate after therapy, and this is well known in many studies. But if they access an AI and, you know, end up involved in that to the extent where a lot of these self-reinforcing networks and loops become even more self-sustaining, then you can end up with some very, very horrible outcomes.
You mentioned the enshittification of care, I think it was.
Oh yes, the enshittification. It's,
Good old
well,
Corey Doctorow, yes. Yeah, I've met him before. I
yes.
got to interview him about 10 years ago.
Yeah, and I assure you it's coming. The enshittification of AI is absolutely going to, things are going to get more expensive, less available. There's no way in which you can maintain the cost model as things stand.
Right, yeah. So, but it's specifically applied to care
Yeah.
in terms of psychology, and I'm worried that yes, that it may become cheaper, it may become more accessible to people, but you know, the incentives behind its development may be not aligned to the interests of those who are taking, you know, the therapy. In fact,
Either
it
the
may be
people or society
used as a
itself.
form of persuasion, which I'm worried about too. Sorry.
Oh yeah, you could do a lot with a cult, I imagine. If you're a cult leader and you had a good AI aligned to your goals, you could, yes, you could do terrible things.
Yeah, so in what ways do you think, like for instance, if people become too reliant on this, because, you know, it's not cheap to see a psychologist or a psychiatrist for people who aren't on a Medicare plan or something like that. For people who, yeah, I imagine that this kind of therapy may be a way that well, it could be a doorway or like a wedge into a new form of persuasion.
Yes.
So I'm really worried about that kind of thing.
I think that used in conjunction with a good human therapist, you're going to get some really good results, better than you could alone. Faster, better results there. But without that guidance, without that things going off the track awareness on the part of a human, yes, I'm concerned not just for the people themselves, but for the ramifications for broader society for multiple reasons.
Well, I mean, obviously in the future AI is going to get better in many ways, but I guess the
find
waterline...
the word better is doing a lot of heavy lifting there.
It is, yes, but the waterline of capability is, okay, so you get your peaks and your troughs in AI capability, much like humans have peaks and troughs, but AI doesn't have that sort of lived experience. It's not sentient as far as we understand. It doesn't have raw feels, and it certainly doesn't have our psychology. In what ways, if it's inevitable that AI is going to get better, if it's highly predictive that AI is going to be used for aids in various care disciplines, whether that be psychotherapy, psychology, old age care, medical triage. In fact, we have somebody talk about medical triage later tomorrow.
Yeah.
What ways would you say we should focus on improving the aspects of AI which are somehow deficient now? What would you focus on?
I don't think I'd be trying to do that particularly, because that would be what the aspects that it does well now is going to continue to do well and do better on. Those new psychoeducation aspects, the ability to take an algorithm and work through it with a person and patiently explain every step as you go through it. It already does that quite well, and it'll continue to get better at doing those. I don't actually want to broaden it beyond those things that it already does well, because that's where I see the traps. That's where I
Right.
see the non-human aspects really being a ceiling on how it can be helpful, and that is the point at which it starts becoming counter-therapeutic.
Right, so if AI does seem to get more human, at least performatively more human,
Yes, yeah. That's
that's the worry, is it?
That's it.
Yeah.
That is it. That is it. That is where you fall into the uncanny valley and head off down there.
Mm-hmm. Sure. Yeah, it's also, I mean, when we see that AI is doing reasoning, just something simple, it's often performatively doing reasoning, where it's actually just doing pattern matching under the hood.
Yes.
It's not doing, you know, you can't trace its logic. Even it hallucinates to itself when it uses a scratch pad outside of its main LLM brain, hallucinates onto the scratch pad, then ingests the hallucination back into the LLM, and obviously things go like pretty bad from then on. So
Indeed.
it's this, if it's not actually doing reasoning adequately underneath the hood, yeah, sure, there might be a lot of data out there for it to perform more accurate pattern matching, but if it's not actually understanding the logic or the reasoning behind what it's actually spouting out, bad things can happen at the edges of its certainty, where, you know, out of distribution events or counterfactual scenarios where there's no real data to support.
Yes, or where the data is skewed in one direction or another by publication dark bias and that sort of thing. And as I mentioned, the large meta-analyses are terribly, terribly skewed by various things, such as drug companies do not do trials on older medications that are often still extremely effective, because there's no financial incentive for them to do that. So large quantities of data that would be extremely important for accurate risk management in medication use are simply missing or distorted because of the presence of the wrong kinds of data in overwhelming numbers.
Yeah, that reminds me of the issue of not being able to do experiments on children for obvious reasons.
Yes.
Now, because of that, it makes it really difficult to test whether medications work on children, right?
Yeah.
And that in itself is a risk, but I mean, it's a risk we're willing to take, because we don't want to necessarily put children under the risk of, you know, untested medicine. I don't know, like, but yeah, on the other hand, they've built all sorts of new artificial biology systems, like systems biology. They've even grown organs on chips to behave like human biology. So yes, I mean, they're trying to work around the issue of not being able to test on children.
I know. It's fascinating, though. If you look at the issue of one organ in isolation, yes, you can fine-tune a very specific organ, but if you put that into the system of the person, the human body as a whole, you can guarantee something's going to go wrong, upstream, downstream, mess the whole thing up in one direction or another.
Yeah, that's true.
Yeah. Really complex systems.
Yeah, it is. And I mean, like, I'm not against these systems, because they help reduce. If you can do some testing in systems biology, some testing on advanced sort of pipelines of organs on chips. you're reducing the risks of the test patients that end up having to trial these. The human trials become less dangerous for the humans involved, and also the speed in which you can get the therapies out maybe better, and it's cheaper to do. So it's got some benefits as well.
It definitely has it. There's a lot of good points about the use of AI in psychiatry. I'm not anti it at all. I'm just aware of its limitations.
Yeah, and it's good to be aware of those sorts of things up front and not be too Pollyanna about, like, hey, I've got a psychiatrist or a therapist in my pocket.
Yes, I was just reading another one about somebody who, again, became extremely addicted to their AI therapist and suicided, I think, just a couple of weeks ago after they'd been cut off from it by their family. It's just very, very difficult and tragic stories emerging from that space at the moment.
Yes, and we haven't had a lot of time to actually look at the actual underground effects of these sorts of things. And yes, I've heard of all sorts of AI-induced psychosis.
Definitely
examples
that too.
happening.
Yeah.
Right.
Yeah. It's fascinating, the folie à deux as a phenomenon where one person has the index psychosis, and they're usually in a close relationship with someone who may or may not be to some degree dependent on them, and the original psychosis of the first person becomes shared, and it can have folie à quatre. It's just called folie à deux for simplicity's sake. It's generally siblings or a married couple or something like that. But if you treat the index psychosis, the secondary one usually resolves on its own, but it never would if it was being maintained through an AI kind of self-referential framework.
Lydia in the audience has asked a few questions.
Oh, yes.
One of them is, okay, what hidden patterns in mental health do you think AI will uncover first?
Oh. That is almost an unanswerable question, because if I knew about them, they wouldn't exactly be hidden. I think what we're going to see, though, is a really rarefied understanding of symptom clustering. What we've got is the result of Carl Jaspers, Carl Baum, etc., looking at these vast asylums in the 19th century and categorizing people by the symptoms, as we mentioned. And then you have these concepts of schizophrenia, schizoaffective disorder, bipolar disorder, and there's subcategorizations there. And what I think we're going to get is a much more finely nuanced understanding of specifically what kind of symptoms within, for instance, the psychotic domain might map onto particular presentations that might do better with particular forms of therapy. I think that's a very exciting field. We haven't had the depth and level of data and the ability to really look at the nuances of it as yet, and that is a quite exciting field there. So working out if somebody has, for instance, somatic delusions or delusions of infestation, whether there's a particular antipsychotic that might be a lot better for that person in terms of recovery. I mean, anecdotally, amisulpride does well there, but the data isn't there to back that up.
That's really interesting.
Yeah.
So, yeah, there's a lot of literature out there around a whole lot of fields. So much of it is very sparsely distributed, right?
Yep.
Now, AI seems to be very good at finding disparate, sort of sparse, sort of interesting, nitty-pick data across huge volumes of text out there and different studies and all that. It might be able to help marshal some of the and correlate some of the interesting findings in ways that humans don't necessarily gravitate towards.
Especially when you correlate it with the findings of the Human Genome Project.
Right. Yeah.
Because candidate genes. I mean, there's at least 40,000 identified candidate genes for schizophrenia at this stage, and that's just going to get bigger. But looking at the patterns in which they appear, the constellations of genetic individualized signatures underlying the patterns again of symptom the nature of symptoms when they appear, how they interrelate with other symptomatology of the person, all that sort of thing, and biological signatures such as sleep activity, biorhythms, all that sort of thing. Yeah, I think there's fascinating and wonderful things to come in that particular area too. That's not AI as a therapist naturally, and I think there's almost no downside to this particular aspect of AI in psychiatry.
Yeah, you're right. So on an individual day basis, you've noticed there could be harm to neurodivergent people
Yeah, yeah.
because they can be neurodivergent in a rather wide amount of ways. So one specific type of neurodivergent psychology that somebody has may be completely unfamiliar to a psychiatrist.
Yes, true.
So maybe AI might be able to help sort of find specific potential harms or potential boons that autism that somebody trying to treat neurodivergent people might overlook. What do you think?
Yes, that definitely has potential, and Sister Communication has already made quite a bit of a revolution there. AI in the realm of assisted communication it's exciting, but I don't know if you're aware, but there was 15 or 20 years ago, no, a bit longer, there was something called facilitated communication, where you had human therapists working with non-verbal people and doing what they said was facilitated communication, where the person would do something that would be interpreted as meaning something else, and it was all very, very tragic, because with the best will in the world, these therapists were unintentionally making things up. So they would say this person's been subject to abuse, and there were court cases against parents, that sort of thing, based on nothing but a rescue fantasy of a particular carer. It was all debunked. It was a horrible situation. Terrible things flowed from it. And I am fearful that AI again might fall into that sort of trap if you're using it for that kind of facilitated assisted communication side of things. Having said that, the chance of somebody with a very divergent profile that's almost not understandable by most other therapists, I think there's potential for a lot of good there as well.
Yeah, that's a sad story.
It is. It was a shocker.
Yeah, it would have been really maybe even embarrassing for the families involved. They could have got
Yes.
demonized and that sort of thing. Yeah, it's a very fine line that you've got to tread there, because yeah, terrible. Let's have a look. Lydia might have asked some other questions. Here we go. How do we ensure AI findings are clinically meaningful and not just statistically impressive?
I wish we could do that. I mean, there's been not just psychiatric literature, but medical research has been absolutely bedeviled by statistical analyses being elevated to a godlike sort of status for the past 20 years at least. We're not doing it well now. I don't think we're going to do it terribly well in the new realm either. Having said that, is there anything useful I can say there? I think maybe with the relative ease with which statistics can be manipulated by AI, it might lose some of its magical totemic significance, which would be a good thing if you ask me. But I see, I'm also seeing a lot of terrible AI statistical analysis too. I'm not sure there's much good going to happen in that field. Maybe Lev would have a good idea on how to inoculate the field against terrible stats. Sounds like your kind of thing, Lev?
Is he there? Hi, Lev. He might not be at his terminal. Yeah. So you mentioned the exposed, the psychiatrists feeling or being exposed. So what kind of things do you think psychiatrists have, or the whole profession has been sort of inadvertently or on purpose hiding, either bureaucratically, clinical distance oriented, behind technical jargon, that
Yeah.
AI might help shed light on?
I think that psychiatry, as with many fields where there's a sort of a priesthood, I'm not sure, where there is,
Priesthood.
well, self-selected, the people who hold the knowledge and
Mm.
who dole it out to others, there's a terrible tendency to become all mystical about it. And if you try to read some of the more obscure postmodern psychiatric influences, such as Lacan, that stuff is deliberately made up to obfuscate. I swear I can't read Lacan without getting thought disordered. No offense to any Lacanians in the audience, but that is not accidentally opaque. So yes, the tendency to accentuate one's own knowledge base and make it impervious to others is a natural human tendency, and it's more likely in fields like this where that is that self-selected hierarchy, aristocracy of knowledge. And psychiatry has most certainly fallen into that trap. The people who write well in psychiatry are not those who come up with the grand designs and the new theory. They're the ones who are deeply human, who think about humans in a human way. Winnicott, Bowlby, I mentioned them all before, but other people who sit at the nexus of psychiatry and neurology, like Sachs, do it extremely well, elevating and understanding and prioritizing the human above the concepts that we impose on human relationships and ways of thinking and pathologies.
Mm-hmm. One of the things that another speaker, A.L. Aharoni, who was the lead author of was the original moral Turing test paper,
Yeah.
he's now engaging in a study to test how well medical triage systems in rural settings, in outskirts, like in hospitals where they're understaffed and they don't have, the resources to deal with things, or the money to. He's going to have these like AIs step in and help with medical triage, right? So, from a psychiatrist and a psychological point of view, addressing this digital divide. You're a supporter of rural psychology. Do you worry that the AI front doors will become a permanent backdoor for rural patients, essentially creating a two-tier system where the wealthy get human specialists and the rural population gets high-end chatbots? Or on the other end, will it help, reduce the fire hose effect, where there's so many people in need that AI can help deal with lots of people?
I really like that question. There's a lot of nuance in it. I think that, yes, absolutely, rural services, they already have a very significant two-tier system in place already. At the moment, if you can't afford private therapy, then you do end up with a very understaffed, understretched, time-poor, crisis management-driven public system. I think that a high-end chatbot could really add to the experience for many people in that setting. I would hate for the human element to be replaced there, but I think again you could really, really usefully work with a partnership between humans and AIs there. Having said that, though, there is a lot of over-pathologization of human distress that occurs in every aspect of psychiatry. Many things become labelled as pathological when they're understandable reactions to the environment and don't necessarily need to be considered as disorders. I would be concerned that the fire hose might actually be broadened as a result of that kind of access there. I don't think, well, for instance, the rapid response in traumatic situations where people were given trauma counselling as an acute response actually increased the rates of PTSD for people after that. Didn't improve it, it actually increased the diagnosable rates of distress and trauma. So I think you can easily have too much intervention. I think you can over-pathologize. I think you can over-medicalize. And you can certainly lead people to believe that they're broken when they're just in distress. I'm not sure I've actually answered your question there, but it's a lovely digression.
Yeah, sure. Lev, did you have a question? He appeared for a moment.
He did.
He did. Oh, there he is. Just half a second. Oh, here we go. Lev, you're
I
muted.
did catch what you were saying before, but I was away from the keyboard.
Yeah, fair enough. Fair enough. The statistics side of things. How can we?
That's right.
How can we inoculate?
Oh, I don't know. Look, there are a number of statistical measures, but I mean, ultimately, it's like, you're looking at empirical verification.
Yes.
And you would do there's the whole range of tests, and so concurrent tests, and
AI might be able to help replication
a whole
studies.
range. Well, I mean, it could certainly help in that regard, because you would be when you're in econometrics these days, and develop further from that, the statistical tests show greater levels of causality, with different variables. So yeah, again, I mean, it's look, it's the sort of thing that doesn't require a supercomputer, really. It requires somebody who basically just write out the math and have some clarity as they're thinking, and do the comparisons.
But then once it's done, to think, is this actually adding anything to some of human knowledge? Was it worth doing?
Oh yeah, look, yeah. I certainly think it does, actually. I mean, for a very long time, there was a lot of debate about how you actually do, tests for causality. But now there's now that they're a lot stronger. I think there is actually, the empirical tests are a lot better. I mean, look at things like things like Granger causality, for example, where there's whether you can get statistical hypotheses testing against one-time series use, or whether it's useful for testing for another. I mean, they're fairly useful in that regard. And it's funny to think that actually initially came from this sort of thing came from found its widespread application initially in econometrics, but of course econometrics was it was because it was such a competing field back in those days. The statistics got a lot stronger after time, so that's that helped a great deal.
Interesting.
Would be interesting for psychology and psychiatry.
I just had a quick look at Lydia's other questions there. I'm not sure I've answered them all. Oh yes, accountability, yes. I don't think we've got that question answered at all. If AI-assisted diagnosis is wrong, one would certainly hope that if it's assisted, that the person who is working with the AI system would be held accountable for that. Misdiagnosis in the overlapping symptom landscape. I think one thing that does get overlooked is that if any one thing has gone wrong with somebody's brain and mind to the extent that they have any of the diagnosable mental health syndromes, it's kind of likely you'll have elements of more than one there. There's an overdetermination about pathology. And so misdiagnosis is not, I think, as important as just having a diagnostic hierarchy and working your way through it. I think AI, if it's able to do that and follow it and assist with that algorithmic process there, could be helpful in inducing unhelpful diagnoses or ones that need to be relegated down to the opposite end of the treatment hierarchy. But yes, there's a lot of overlapping symptoms in that landscape. You're absolutely right. The aspect of therapy AI can never replicate. I think I did touch on that. I think in terms of just the being human with somebody, the ways in which we are coded, in which we are wired to recognise and assess and understand eye contact. All of those just basic biological functions. Obviously, AI can't do that. And just knowing that it's another actual person in there, they could have chosen not to be sitting there with you, they could choose not to make another appointment with you, that they're there by choice, even if you're paying them, it's still by choice. That aspect as well.
Well, AI is having quite a destabilising effect in the world now.
Yes.
If some of the predictions about unemployability in the future become accurate, there'll probably be a lot of grief and a lot of anxiety and a lot of psychological conditions that as a result of not being able to work, or losing jobs and losing income and all sorts of downstream effects.
Yeah.
So how do you expect, psychology, but psychiatry be able to be able to handle this potential snowballing effect of more and more people having issues, psychological issues, because they're losing their job, losing their income, losing the things which they need an income to support, like mortgages and family and things like that?
I think the crisis response is one thing and the longer term response is another. The crisis response is appropriately part of psychiatry and psychology. The longer term response is fundamentally much more a sociological question, and I don't think we should be trying to therapize our way out of that aspect of it. I think that social settings, political settings will need to change, new norms will need to be valorized. That's not really the purview of what psychiatry should be doing. I don't like psychiatry as a tool of sociology. I think bad things can happen there too. But for the individual who is struggling with that process, I think definitely for psychiatrists being aware that that's a coming tide, being comfortable in talking to people about that in an area that may still be threatened ourselves. It's certainly something that is better talked about than not talked about, even if our individual therapists are feeling threatened. And being human with the person, not necessarily against the eye, but in the context of what is happening and what is changing, and trying to, what I said before about turning struggle, turning distress into meaning and action through that relational alchemy. I don't think there's any more noble thing that you could be doing in that moment and with that pain.
Yeah, that's cool. It seems as though there's a lot of, psychiatry is a very skilled discipline, right? You don't get to be a psychiatrist by going to, like a 6-month TAFE course. Or going to 1 year of university. But if the scale of impact of AI replacing human labour causes a lot of psychological grief, a lot of psychological issues in humans, and humans then might just start depending on bad diagnoses, maybe drugs that haven't been tested well, or drugs that don't suit them.
Yeah.
How do you think? Well, as you said, might be a sociological issue of trying to get more psychiatrists trained up and ready to deal with this rising tide, maybe.
But
What do you
also,
think?
I don't think it should just be psychiatrists. I think everybody working in a public-facing role. So you should start up by properly funding Centrelink and staffing it well with people who know what's coming. You'd look at how to find meaning for people who've lost their jobs, what other areas that are creative, meaningful, worthwhile, what other areas of life they can engage in. So that would be, what would that be? What field would that be? I suppose it would be public health, really, wouldn't it?
I know a philosopher wrote a book about this, Nick Boston, Deep Utopia, very worth a read. But you know, there's a bunch of other people who've got sort of theories about meaning generation and the way that we might be able to do things that have meaning. After all, people who retire still generate meaning in their life, don't they? Right?
Variably.
Yeah. Well, I mean, some of them do. That's right.
Yeah.
Some people are good at retiring.
Yes.
And maybe because they've been able to find things to do in life that give them meaning. Gardening, maybe, you know, playing chess, or
I think gardening's
having
pretty safe
games
from
with
AI.
people. Yeah, for the time being.
That's
Yeah,
my thing.
Yeah, well, I mean, anything that's sort of you know, any kind of intellectual activity could be in some way algorithmatized in ways that we can't really imagine today. When I say algorithm, that's a very broad term. I'm using it in a very broad way. I don't mean just very in a simple way.
I think though that the results are less important than the doing. For instance, I sing. I'm sure you could get an AI version of my voice to do all sorts of things, but I love the singing. The
Yeah, you like
singing,
doing
the
it.
performance itself is what gives it meaning for me.
Yeah.
And the outcome, whether an AI can do it better or turn it into an algorithm that works and gives a nicer product, that's not the point. That's not the meaning.
Right, exactly. Yeah, it's not about being the best. It's not about, you know, trying to compare yourself against the masters who may be AI in the future. It's about actually engaging and it's something for yourself, and it's also the interpersonal relationships you get with doing these sorts of things.
Yes.
You know, it's joint projects, the sort of meaning you generate by relating to other people who either doing something that appreciate what you're who just appreciate what you're doing, or you appreciate what they're doing, or joint projects.
Yeah, all of that, definitely.
Okay, let me ask. So you're a fan of more time, more spare time. Well, you might have some. We all might have some.
We might indeed. I do have plans for it.
Yeah. Well, that's good. I mean, and that's part of the maybe the solution to the last question is get ready. I mean, it may come sooner or later, or it may not come. This AI revolution that takes many jobs. I think it's happening, but maybe it won't happen to the extent that some people think. Maybe it'll be even worse, right? Or maybe quote unquote worse. But
I think mileage will vary in different areas and at different times.
yeah. So what would you be doing with those extra hours if you had them? Would you be playing violin,
Yes, so
LARPing, costuming,
yes, all of those.
attending Renaissance festivals?
I would also continue reading. I've got projects going in various reading directions. Through my way through various classics, I would curate conversations with people who I find fascinating. I would probably do a bit of gardening, even though I'm terrible at it.
We don't have to be good at the things that we enjoy, right?
Exactly. So I already have identified the things that I would do more. I'd do a lot more of those in a much less pressured sort of a way. It would be fun.
Yeah. I wouldn't mind trying to master a few things that I think I'm naturally not very good at, just to see, right? Like I've never really been good at picking up other languages, for instance. I might try something like that. You know?
Yes.
Or cooking.
Oh no, yes, I do love cooking. But yes, so all of those sorts of things, and just doing things that create pleasure for me in the moment and for people around me in the moment.
Hmm. What
Happiness
worries?
rather than pleasure.
Yeah. Okay, back on the doomy sort of stuff. What
Yes.
worries you the most about the future of where AI is going? Is it the actual AI and what it can do, or is it the people using it, or
Oh,
is
I
it
think the
the
people using it are
dynamics
most.
surrounding it? Yeah.
Okay, I think the people in charge are terrible people, mostly, with a couple of exceptions. I think their lack of morals and their willingness to elevate the profit motive and work with very dodgy organisations is a terrible sign, even at this fairly early stage. So there's a major red flag. I think, though, that the doom and gloom it's going to destroy us all side of things is exaggerated. I think we would be seeing more coherent bad action from AI actors by now if that was going to be a major threat. Mind you, I'm not an expert in this area, but that's my feeling. I do think that some of the bad stuff would really be emerging, whereas most of the bad stuff now is accidental. It's either accidental in forms of hallucinations, or it's just terrible advice, or it's people knowingly using this tool to terrible purposes, rather than a function of the AI doing it itself. So I'm relatively optimistic in those terms. It is rather a shame that the things that AI is mostly used for are things that should be creative and done by humans. So music, image generation, etc., etc. I do think that is quite an early downside, but I also think that the uniqueness and humanity of some of these artisan areas will become more appreciated over time as well. There will be a swing of the pendulum back towards the other side eventually. Possibly, especially if there's significant enshittification.
Yeah. So, unenshittification. Maybe. What can we do to beautify the future then? What are you most optimistic about?
People remaining people. I think that yes, through thousands and thousands of years, if you look at the kinds of poetry people wrote back in Chinese dynasties, in ancient cultures, people are people. I think people will remain people.
Mm-hmm.
So yes, I am optimistic about that. I think that the gestalt of all sorts of things that is a human being and all it means and what it is to be one will remain essentially itself.
That's interesting. It's interesting to think about, what it is to be a human being. I mean, I often wonder about that in the sense of, a deep history point of view. I look at how my ancestors lived. Well, I've never been there. I can't sample their psychology and just put it in my head. We've got all sorts of art. We got the writings, the old poetry. There are some similarities. Some of the the timeless struggles that we have as humans, but
And every single generation, way back in the Romans, are saying the young people today, they're
Yeah.
going to hell.
Yes,
Exactly.
the old finger wagging. Yeah, that's
Timeless.
so interesting. Yeah, but I mean, we do. I mean, the there's always been a want of more time and more freedom, right? I mean, the reasons why agrarian civilization started apparently was because they thought they could automate or make it easier to get food, freeing them up to be able to do more things. People argue, have more leisure time, but it just caused people to generate more products. There was a lot of diseases around that sort of manifest in highly static, highly populated areas.
Very true, yes. True.
You
And
know,
also, once you have a resource that is storable, you have a resource that can be stolen.
Yeah, that's
So,
right.
yes.
Yeah, yeah, and tribes got massive, bigger and bigger. From just small tribes where everybody knew each other to hamlets, to towns, to villages, to cities, to empires. And you could walk down the street and not know anybody, and suddenly you treat most people that you see in the world as cardboard cutouts. Yeah, it's but the human, the being human in the modern world is different, I think.
Yes, and I think it's very important to have to create those smaller tribes around yourself to
Yeah.
remain human.
Yeah. All right. Well, Lev, have you got any other questions, or Lydia? Well, do you have any concluding remarks that you think is the most important, or some important things to take away? Well, actually, pause that question unless Lev's got one.
Yeah.
Do you have any for this point? Yeah. So maybe we can ask you just to, if you've got any concluding sort of remarks that you'd like
Yeah.
to.
As I said, I'm in general on the optimistic side about the effects of AI. I'm certainly not a doom laden prophet in that particular area. But I think that it's absolutely critically important to remain aware of the pitfalls, and particularly at the individual level for people who might be especially vulnerable, to make sure that where AI is used therapeutically or as a triage or a front door service, that is done in ways that balance the risks with the benefits. And that is an area where we should be advocating for government oversight. It really, really is. I'm sure many people here are already quite aware of that, but it's not going to happen by itself. These systems, if they're allowed to grow, will end up skewed, stunted, and with all sorts of abnormal tumours on them. Just to go with what I've got as my visual image there. So being aware of the risks without being doom-laden about them is probably what I would like us to take away from this.
Fantastic. Really appreciate your time and attention to these issues, Angela.
I really loved being asked to do this talk. It was a great topic to think about and work something up on.
Yeah. I haven't seen a whole lot of stuff out there addressing this topic by psychiatrists. There is one that I know of, and he's quite prolific, and that's Scott Alexander, of course.
Oh yes,
but,
yes. I know Scott.
there's not a lot that I've seen. It's great that, he's quite a private person. He doesn't give talks. He writes a lot. He's very prolific in his writing. So it's really good to hear somebody talk about this, and have a face to put to the issues.
A human.
Yes, exactly right.
Yeah.
So thank you so much for joining us and participating and providing your energy.
It's been an absolute pleasure. Thank you for asking me.
Yes. And you too, Liv. I didn't get to say that because we had to fast transition, but yeah, really appreciate your participation and willingness to sort of give up your time and energy to be able to do all this. So,
Look, thank you for inviting me. I didn't get around to sort of spending the time that I was initially planning to spend on the role of AI and all this. But it's kind of like a pre-AI foundation. There's not much you can, if your environment burns, all other cards are off the table.
Yeah, it's coming to save you there.
Unless we have this like Terminator-like landscape, where the robots are just like marching around a desolate, burnt-out husk of a planet.
Yeah, that's right. Yes, that's right. And it's Future Day. There's many things to think about with regard to the future. They don't all have to be about AI. AI does seem to be quite a strong theme, though. It's true.
Yes.
So what do
you
you got
did bring up actually on discussion earlier about data centers.
Yes.
Data centers and
Mentioned.
resource usage.
Yeah.
Very quickly, I will point out that over 70% of greenhouse gas emissions that occur through IT equipment is actually personal devices.
Oh, really?
Whether it's like whether it's business desktops, laptops, handheld devices, what have you.
I'm glad to hear that. That's fairly
Yeah.
reassuring.
There's
Mm.
I'm
like
gonna stop.
the big data centers look scary, but they actually are relatively efficient.
Right.
Good. Thank you.
That's
Again,
interesting.
a scaling issue. It's the way the
Yeah.
brain works,
Yeah,
Mhm.
yeah. Do you think data centers will become more efficient in the future? Or is there better?
Oh yeah, they work quite hard at that actually.
Right.
Um,
Yeah. But
and
there's
as
cheap
a
ways of getting like powering data centers, which are very good for fast scale up, which I'm
mm,
worried about. They build a new gas plant next to a data center just because it's just cheaper to build your own sort of.
but of course, data centers want to be close to where the information transfer is because of latency costs.
Yes.
And throughput costs. So actually, one of the curious things that is becoming more popular in the US for sort of the data centers is actually this sort of like looking towards nuclear
Hmm.
to actually give them the sustained electricity supply in relative proximity to population centers.
Hmm.
I must say there seems to be
Because
a episode of The Simpsons waiting for that one.
yeah, there probably is one.
Hmm. Oh,
So watch
we
this space.
we got to create a nice Dyson sphere and beam the energy in, right? Yeah, yeah. A Matryoshka
All right,
brain.
I've got to go. I've
Hmm.
got another meeting.
Yeah,
All
no
right.
problems, Lev. Thanks heaps.
Thank you for organising this, Adam. It's
Oh, it's good fun.
wonderful range of speakers.
Oh, yes, it has been. I agree. Thanks.
All right.
Okay, I better go
See you
to
soon.
Thanks,
course control,
Angela.
etc.
Mhm.
Pleasure.
We'll see you again.
Bye.
Bye. Thanks, everybody. That's the end of day 2. And tomorrow, or yes, tomorrow, for me it is, anyway, we have Eyal Aharoni in the morning, or my morning, speaking on Turing tests. His talk is Breaking the Moral Turing Test, Studies of Human Attribution and Deference to AI Moral Judgment and Decision Making. We've got Danica Dillian after him, who's also a lead author in another Turing test paper study. And she's talking on the ethicist in your pocket. Then we're going to do a turn to health and longevity with Christine Peterson, who's going to be talking about the top 10 longevity strategies today that you may not already know. And did you know that Christine Peterson coined the term open source? And then we got the prolific and amazing Aubrey de Grey, who is well known in the longevity community for the theory of strategies for engineered negligible senescence. So he's going to be talking on how close are we to robust mouth rejuvenation and why does that matter? Finally, the final talk of the Future Day conference series is Andreas Gomez Emelson, and this is all about consciousness. He's one of the founders of the Qualia Research Institute. Is going to be talking about consciousness. So yes, I'm very much looking forward to all of this, and thanks everybody for listening in and watching and providing such wonderful questions. And signing off, Adam. I'll see you tomorrow.